We're going to continue looking at exponential equations and solving them. Our main focus today is going to be determining whether or not we want to do things with the same base or without the same base, and how to focus and deal with those. So in our first problem, we have 3 to the 2x minus 3 equals 1/9. And so we're going to try to attack these problems by isolating the ideas that would be the base. And so on our left-hand side, obviously we have 3 raised to the 2x minus 3. So the question becomes, how can we write 1/9 as 3 to a power? Well, obviously the way this is going to happen is 3 to the negative 2, because that becomes 1 over 3 squared. Now, since the bases are the same, we can set the exponents equal to each other. So 2x minus 3 equals negative 2. We solve now by 2x minus 3 equals negative 2, so we say 2x equals, we add 3 over, equals 1. And that's going to therefore give us a solving problem of x equals positive 1/2. And so that's how we can solve, by just working these through very, very simply in that manner. Okay, so as we look at these, we're going to kind of play with the different numbers in different ways and try to work these through. Let's look at our next one. Here, we're asked to solve an exponential equation without the same base. So first thing, as before, we're going to isolate the exponential function. So we're going to subtract that 2 and get 8 raised to the x equals 3. Next, we're going to try to change this to the same base, but we can't. 8 is only 2 cubed, 3 is 3 to the first, so it can only be done, therefore, as a logarithm. Just as a little reminder, let's put our logarithm transformational. Log base b of a equals c. Therefore, b to the c equals a. There's our little transforming equation if you've forgotten that. So here we're going to have log base 8 of 3 equals x. Now, this is an exact answer, and so if they ask you for an exact answer, then you're going to leave it in the logarithm form. However, if they ask us for a decimal form, we're going to use our alpha math function, and we're going to plug our values in of 8 and 3. And that's going to give us an answer of 0.5283208 equals x. And rounding that to the nearest 3 decimals, that's 0.528 equals x. So in blue, we have the exact answer, and in green, we have the approximate answer. And it all depends on what they ask you and how to approach that. Okay, let's look at our third one. Over here on the right. First thing, once again, is isolating the exponential form, and so we're going to say 2 times 6 to the 3x minus 1 equals 8, obviously adding the 4 over. Then we're going to have to divide by this coefficient of 2 in front. That's going to leave us with 6 to the 3x minus 1 equals 4. 4 is 2 squared, 3, and that's not the same as 6, obviously, so we're going to have to use our transforming into logarithmic form here. So log base 6 of 4 equals 3x minus 1. We now solve for x, so we're going to add 1 to both sides, and then we're going to divide by 3. Now, as we work this through, we need to understand that log of 4 plus 1 is not the log of 5. That's the log base 6 of 4 plus 1. And then if we want to do our exact answer, we're going to find out the value of that logarithm, 6 base and a 4. Then we're going to take that answer, we're going to add 1 to it. And then we're going to divide that answer by 3. So my answer as a decimal point is going to be 0.591 equals x. So once again, in green is our approximate answer, and now in red is our exact answer. So these are 3 examples of how to approach problems if they have the same base or possibly don't have the same base. But in the first case, just as a reminder, we're going to try to write each side with the same base and then solve that very simple equation. But down here, we have exact answers versus approximate answers. I hope that's been helpful in understanding the second part of our material for today.